I can't count second grade, so I'm used to getting people's attention. So I'm Maggie.
I'm Alicia.
And ours is MP1.
That's kind of the definition, a general sense of it. It's making sense of problems and just getting through solving them for the most part.
So we chose one lower level math problem, which is up here on the board. It says Sarah needs to fill up water balloons for her birthday party. She's holding the balloons in 3 separate 1-gallon buckets. Each bucket can hold 15 water balloons. How many water balloons can Sarah fill up? And we've given 4 possible answers for the students. A, 30 water balloons, B, 45 water balloons, C, 50 water balloons, or D, 15 water balloons. And then we ask the question, how do you know? Because for us as teachers, as adults, this can be a very simple problem. But we have to remember that for our students, they need to take that process of thinking through why is it one of the given answers.
So we did a higher one too that kind of played off that lower problem. And keep in mind these are elementary problems, so they're not very difficult. But this one, Hannah needs to fill up 350 water balloons for her birthday party. She has 4 1-gallon buckets to place the water balloons in. What is the most amount of balloons each bucket needs to hold, so that way all 350 balloons are in 4 buckets? Well, if you divide 350 by 4, you don't get an even number. You get 87.5, and obviously you can't put half a water balloon in a bucket, so the children need to think that you're going to have 2 buckets with 87 and then 2 buckets with 88, so it's kind of a trick question, but if you use MP1 in your problem solving steps, that'll help you get to that answer.
Alright, so what is MP1? MP1 is the mathematical, or stands for mathematical practice 1, and is making sense of problems and persevering through them. So students start by explaining to themselves the meaning of a problem and looking for entry points to its solution. They then form a meaning of the solution and plan a solution pathway rather than simply just jumping into a solution attempt. So because that was like the formal definition and I have to simplify things even though it is kind of simple. But so what you need to do is they need to start with the steps to get the solution rather than just checking guessing, like, oh, let's plug in 5 for X or whatever it might be. And then students might rely on using concrete objects or pictures to help conceptualize and solve a problem. And then the mathematical proficient students check their answers to problem using different methods, and they need to continually ask themselves, does this make sense?
So here's a cute little poster that you can put in your room that helps demonstrate MP1, and it's circle important information, underline the question, box the word not so you can figure out what things you don't need, and then again, eliminate unnecessary information. And this can just be on your wall, and it's easy for students to reference if they're stuck in a word problem or any problem that they need to take certain steps to.
And then how can we use MP1? The standard encompasses the student's ability to solve problems by applying varied math skills. So there are 3 parts to this. The first is understanding the problem-solving process. And with that, you're using metacognition, which we learned about in our reflections last week. So thinking about your thinking. The second step is developing strategies. So you decide on a plan to lead to the answer. And then the third step is building a problem-solving disposition. Monitor, check, and modify the course of action.
So another thing that you could potentially hang on your wall for students to reference, or they could make on their own, is this graphic organizer. It's called the STAR strategy. S stands for search the word problem, T is translate the problem, A for answer the problem, and 4, review the solution, which is like using your metacognition. And it just ties into MP1 by making more sense of the problem and once again, helping the student work through the problem step by step instead of just jumping all in at once.
There are many different strategies that you can go about to solve a problem using MP1. A lot of them include activities and discussions, and they focus on why and how the students chose the strategy that they did. And then moving beyond the oversimplified methods to solve the problem, 1 or 2 problems to solve, and then discuss why you solve those and how you solve those. Talk and write as the students solve, because a lot of times I found, especially with kids that I work with, that if you're talking through the problem with them, they are more likely to understand it later and be able to summarize it and give it back to you. It's a really good teaching strategy and learning technique. And then make sure to be asking them frequent and purposeful higher level questions. And most importantly, we need to praise our students' efforts, whether they get it completely right or completely wrong, to always stay positive, because if you have a positive attitude about math and about them solving the problem, then it will help them later on throughout their math academic career.
So I kind of explained earlier how we solved that higher level problem using MP1, but just some more steps on that. Number one, you need to go over the problem solving process. What do you want to do first, second, next, and then decide on a plan, and then discuss what you want to do with whoever you need to. Praise your students, ask questions like Maggie just said, and then be aware of why you did what you did, metacognition. And it also helps to use the STAR strategy to solve problems like that, the graphic organizer that we talked about earlier. By searching the word problem, you can find how many water balloons versus how many buckets you would need, and the key word there is most. What's the most amount she can fit in each bucket? You translate the problem, 350 divided by 4 equals how many balloons per bucket. Then you answer the problem, and then you review your solution. Does it make sense?
And then implementing the SIOP methods with MP1, you need to, the teacher must write clear language and content objectives. So write them on the board, because not only saying it auditorily, but also writing it on the board, as we know, will help the our students to just understand it and have it more concretely in their thinking later on. You also need to be clear with your students on what the class will be doing and why they're doing it. We talked a lot earlier with the last presentation about how Common Core a lot of times is why we're doing it, and that's, I think, is the most important part of Common Core. It's important to adapt the content of the lesson to the proficiency level of your ELL learners. And then to scaffold, to ensure that the right amount of support is being moved for the students from one level to the next. And then it just says to look at every student and decide where they're at and if they will need extra help. And then also, you need to allow your students to work and discuss with each other and with you as the teacher, as we saw in their last presentation, which was really good, to have us discuss first, because a lot of times students, and especially us as college students, we're like, oh, I don't want to answer that first, that's awkward. And so, like, to have that discussion and break down those barriers. And then also to have differentiation within the small groups and the whole group, because if you have some students who are at a faster pace learning, you could either intermingle them with the students who are not getting it quite right, or you can have them moving on to something a little bit higher level. And then also provide hand-on manipulatives. I know in my classes that I work with, we have those like counter blocks when you like connect them and it's like 110, etc. So you can use those, or in this case that we had with the balloons, you could actually bring in like a gallon bucket and then fill it with balloons and hope that none of them pop. And then that's a great tool for all of the learners, and it really helps them to have that hands-on perspective. And then the last thing is just to engage your students 90 to 100% of the time. Allow them to do the experiment themselves, but also be on hand for that if they have any questions. That's
it. That's all.